Hey, welcome to QBRI. This is Quantum Biology Research Institute. My name's Dr. Kieran Johnson. I'm a quantum biologist, and I'm going to talk to you about the He-BEC singularity, or a helium Bose-Einstein condensate as a singularity before the start of time. Sit back, relax, and strap in your seatbelts, because this is time travel. The He-BEC singularity is a model for a very large superatom of helium as a Bose-Einstein condensate. And it's a model that allows one to identify the origin of the speed of light, as well as the formation of dark energy and dark matter from this very large singularity. Because all the electrons are essentially at the ground state, that means that there's no contrast in energy levels between one electron and the other. They're identical. So all the electrons are identical. All the positrons are identical to the electrons. In fact, because there's no motion, there's no mass, no charge. And in a sense, you don't know where there's a beginning and an end between the large sphere of helium and space. So it really has no boundary between space and the singularity. There's no contrast. So the idea really is that it's a model that allows everything to be there prior to a beginning. And then the model allows you to come up with specific parameters based on known fundamental parameters of a helium Bose-Einstein condensate that we've made here on Earth, and apply that logical thinking to the entire universe, but also to ourselves as a single egg. So the idea is to look at the various parameters of distance and velocity and understand how that can relate to the composition of the universe, dark energy, dark matter, and how those transitions from this helium Bose-Einstein condensate can lead to an outcome of the 26 or so cosmological constants that we have for the universe, and how we can go from this state of a helium Bose-Einstein condensate, the He-BEC singularity, to a universe that we have today 13.8 billion years later. That's 68% dark energy, 27% dark matter, and 5% matter. So as an indication, I suggest you do some reading, but from my perspective, the He-BEC singularity has all the information required to be able to predict the speed of light from the decay of the velocity of alpha particles emitted from the helium Bose-Einstein condensate. The diameter of the He-BEC singularity of c squared is corresponding to the distance of twice the speed of light. So the He-BEC singularity has a radius of the distance c, corresponding to 299,792,458 meters. And when you utilize those parameters and you have a implosion or inward trajectory at the square root of the emitted light at alpha particles based on the binding kinetics of the fundamental particles within the He-BEC singularity, then you get numbers that correspond to the gravitational force inward trajectory and the inflationary phase of the universe at 9.97 times faster than the speed of light, emitted alpha particles. The model is very elegant. It utilizes the conversion of the binding energy of helium in the singularity based on a distance apart of 4e to the negative 14 meters, and that's corresponding to a kilojoules per mole analysis. So converting it into kilojoules per mole, we get a velocity corresponding to 299.0637811 meters per second. And it is really the differential speeds that are corresponding to the production of the limit of the speed of light. So that higher velocity of the alpha particles emitted, when they undergo a decay, they are converting this velocity into mass, into a angular momentum, and into the formation of positron electron pairs. And we can see that where we can derive the delta difference between the velocity of alpha particles emitted and the velocity of light. The difference when you divide one by the other, it gives you 9.97 times, which is approximate to the pi squared. So this model is very, I guess, helpful in trying to understand where particular cosmological constants arise and the composition of the universe. So you can calculate the various compositions of dark matter, dark energy, and matter based on the supersymmetry inversion model of helium. And I'll talk about that on a different page.